Okay, I suppose we can start. So, today I'll try to be short spoken, not like last time. So just a short presentation about APIs, how to build it, how to do it fast, easy, and a good result. What we call the best practices. So let's start. As a web developer, today I'll be talking about not API in general, but about specific kind of APIs. It's a RESTful web API. I got a lot of experience working with it, like a client and like a developer of APIs. So I'll tell you about this one. REST means representational state transfer. It's not a standard or a specification, it's just an architectural style, so it doesn't make any requirements for you, for developer. It's just a set of devices, maybe, like a concept. So when you build your API in RESTful style, you could do a lot of different things, but at least you should be conventional. Yeah, so RESTful means such API like any API that conform REST style, and web, that means that it mainly uses HTTP protocol. So next slide. Why do we actually need to create good API with good design? Yeah, the main reason is because when the API is deployed and being used by any client application, it's really hard to change it, to update it, change implementation or convention, because there are dependent users existing when you already deployed your API. So you should think about good design before you implement it and deploy it. It's quite major reason. And for example, in case of public APIs, they're almost forever. You can't just remove it or just change it without any notification. So it should be designed really well. So what can we call a really well designed API? It could be a small part of code, or it could be a really large and extensive API, like for PayPal or another large service. But anyway, it should be easy from the all perspectives. It should be easy to learn for every user, that every developer who uses this API. It should be easy to find out how to work with it. It should be easy to use, also as a client developer, and it should be easy to extend. That's one is from perspective of developer who develops this API. So it should be easy in all kinds. So how can we achieve that? First of all, our API should be consistent. Yeah. And in the second place, it should be consistent. And again, because consistency is probably the main requirement for a well-built API. And yeah, let's start from now. I'm gonna tell you about details how to build some beautiful API, but there are a lot of my own experience here, some examples. Just my imagination. Yeah. So first of all, you should version your API, and the reason is again the same, because when you create your API once, you won't be able to change it just on the fly, because clients will occur any errors, some errors, if you just change it without any notification. So the main practice here is to create a version of your API and in case if you really need to change something in your API, you just create new version of it. So good practice is to put the version of your API in the path, in the URL. For example, like here, v1 peers, v2 pars. Here is a bad example. This URL also has a version, but it's placed in query parameter, and it's quite difficult version number, so it could cause some errors sometimes, some difficulties. So let's go to the next one, URL making. Because API actually contains just a list of some endpoints. So it's like, like interface of your server application. So the names of this API, of these endpoints should be simple, should be always the same, should be consistent, as I say. So main rules here are use lowercase always, because some browsers can treat lowercase and uppercase differently, and actually it could just mix you sometimes. So you should just become consistent and use lowercase everywhere. Use plural nouns. Don't use verbs. It's also quite important, because using verbs may make your API, unpredictable. So user looking at the endpoint URL sometimes just can't say what does it do. Yeah, and use entity identifier. I made a misprint, but ID alternation for sub-resources. For example, like here, I can write bars, some identifier of bar, beers, identifier of beer, and for example, if I request this resource using get method, I supposed to get some kind of beer by this ID from some kind of bar by this ID. Here is a bad example. It uses uppercase, it uses verbs, it uses some, combined parts. It's, I don't know what to expect from this API endpoint. So, next one. Next one is about HTTPI verbs. There are quite a lot of HTTPI verbs in the protocol. For example, options, head, patch, trace, connect, and a lot other. But usually we use only 4 of them. There are get, post, put, and delete. This set of verbs matches with CRUD concept. CRUD concept is create, read, update, delete. So these are only 4 operations that we can do with our entities, with our objects. Yeah, but sometimes, we can use some other verbs. For example, patch quite often is used for partial update of resource. Yeah, and here's quite detailed explanation for get work. It's used to read objects, to read resources, only to read it, not to change. Never use get to change something. It's idempotent. That means that every call of this method, get method, always occur the same result. For example, I can call the get request 10 times, and 10 times I get the same result. Of course, if the resource wasn't changed until while I'm calling this get request. And yeah, other feature of get request is that we can use query parameters to send additional data. We don't have a body in get responses, so we can only use query parameters. We can use them to achieve paging, sorting, filtering, and other different purposes. For example, we can specify fields that we want to be returned. We can specify format of data that will be returned, etc. Here is one good example. I wanted to get a list of beers from some specified bar. I specify ID of bar, now beer, and after this question mark, I specify my query parameters, like limit and offset. They are used for pagination, and sort. For example, I wanted to get a list of beers sorted by string, and this plus sign right before the string means that I want this list to be sorted, for example, by ascending, or descending if I put minus here. So here we got a bad example of call. I don't know what to expect from this URL. I just, for example, using this URL, I can try to create a new record in our database. For example, I wanted to add new bar into our bars, some table. Let's imagine that there are table bars. And here, right in query parameter, I try to send some information about this new bar. So right here, I'm trying to create new entity using get method. It's completely wrong. Never do this. So let's go further. Next verb is post. It's usually used to insert new data, or sometimes perform some different operations. The main difference from other verbs is that every call creates new entity or makes some new change. So, for example, if I post some request 10 times, I'm supposed to create 10 new entities. Here we usually send data in the body of request and don't usually use query parameters. Anyway, it's not prohibited. We still can use query parameters, but the best practice here is to use data in body and the identification of resource in the path. For example, here is just simple post URL, bars, ID of bar, beers, and the body. For example, I wanted to add new kind of beer into my table. I send JSON with name, string. I wanted to add beer Zhiguli with string 4.5, and I expect that will be done. Here we got a bad example of call post methods. I'm gonna do the same, but I use query parameter to add new entity into my table. Why don't we use query parameters here also? Because some browsers, usually old browsers, for example, old versions of Internet Explorer, have quite strict limitation of query length. I don't remember what exactly, maybe 2,000 of symbols. And if I try to send a lot of data using post in query parameter, it will be cut, or maybe it won't send at all. Now we don't have such limitations, but anyway, we don't use a query to send data. Let's go further. Put method is used to update existing data, and as get method, it's idempotent. And again, that means that every time we call this method, we will get the same result. We can call it 10 times, 10 times, we'll get the same result. It just updates the same entity. As in post method, we send data in the body. Good example of usage put method is, it looks like a post method. Only one difference, that post method will create new entity and put method just updates existing one. For example, for previously created beer, I can change some attributes, some properties of it. And suppose I got the error here, I should specify an ID of the resource I want to change. Yeah, here we have to get slash and the ID of the beer I want to change. Sorry for that, but anyway. Here we got a bad example. Again, I'm just showing that we don't need to use query parameter to send data input method. The last one is delete method, delete verb. I suppose it's quite easy. It just removes existing data, existing resource. We just need to specify identifier in the path, like input method. Here we can say example. So I'm gonna delete beer number 12 in bar number 43. Bad example, I'm gonna use query parameter to specify the beer I want to delete. Anyway, you should understand that that example and my previous bad examples will work too. They are acceptable actually, but they're supposed to be a bad practice. Next one, HTTP headers. In good API, you always should care about your HTTP headers. You should specify content type, accept header, and a lot of them. There are a lot of headers that you should take care of. For example, you should specify your CORS configuration. If you want your API to be used by different browsers, by AJAX, requests, etc. Let's go next. Response. Standard format, data format nowadays is JSON. It doesn't mean that you should use only JSON. Yeah, some situations you can use XML and a lot of different types of data, but JSON is simply, it's short, and it's quite widespread right now. For web development, it's a de facto standard because it can be used in JavaScript code directly, like an object. Here we have a good example of getting list of bars and the response in JSON format. For example, I want to achieve a fetch list of bars from my database, for example, and here I get receive the object, JSON object. In this object, I can find offset, limit, and total. These values are used for pagination, and the data directly. This data is array of bars. In this example, we got only one bar. It's called vault, with type div, something like that. Yeah, bad example. I didn't come up with any bad example. I just write something strange. So if your server sends in response some data in unknown strange format, it's bad. Use at least some really well-known format like JSON, XML, etc. Next, HTTP status codes. It's also quite important. Status codes are used to preliminary, to initial, get initial result from the response. There are a lot of different codes in the dictionary, but despite that there are a lot of them, this dictionary of status codes isn't full. For example, we got the code 200, okay? We got the code 201 it stands for created object, but we don't have status codes for updated object or deleted object. So best practice here is for all successful requests, always send status code 200. That means okay, because logic here is such when user sends some request and this request is successful, user don't mind status code at all. He sees 200 and that's okay. Doesn't matter was object created, wasn't, actually doesn't matter. So just send 200 to all successful requests. If you wanted to somehow extend your functionality, you can use some small set of different codes. For example, in our practice, we often use codes 400 for bad request, 401 like unauthorized. Yeah, here are good examples for that. And 500 for internal server error. But anyway, you shouldn't use a whole dictionary of status codes because you never will be how to say it, convenient what code to send in which situation. So just usually select 5, 10 small set of codes and use only them. And here in that example, I put the code 418 and the text for this code is I'm a teapot. Yeah, I know it looks strange, but it's real text from this specification of HTTP status codes. It's kind of a joke. I put this example here just to show you that some status codes are quite strange and you really don't need to use all of them. Let's go to the next slide. Response. Error handling. Yeah, error handling is also quite important part of API building because every API call potentially could return you error. For example, client could make some wrong request, send wrong parameters. Client may won't have authorization token. There are a lot of situations that could return you error. And in this case, you should not only use status codes for errors, but you should return some standard data about your error. For example, in server side, you should always validate your request data, and if some fields are not required for your validation, you should send error. Something like validation error type, and the message some of your requested data isn't valid. Something like that. Here an example, you have different kind of error, but anyway, usually it looks like this. We send error status code, for example, not found, and in response body we send details of this error. Type, it should be some internal code, and the message, short message, what to do, what's going on, something that can help to API client to solve this problem. So also one good practice here is to send a quite more detailed information for authorized users. For example, if user passes authorization and API knows that it's maybe administrator or some user with extended roles, yeah, and rights, we can send to this user a bit more details about the error. For example, block trace, block stack, error stack, something like that. Yeah, and the bad example here, of course, is the empty body for the internal server error. For example, like I'm a user, call this get method, I get the error status code, and I don't know at all what's going on. I don't know what to change. I don't know what, maybe I made some mistake in the spelling. Who knows? So it's quite bad practice, as you see. And actually, that's it. As I said a few times, if you wanted to build good API, you always should be convenient. Not convenient.
Thanks, Mike.
Yeah, I suppose that's it. Thank you for listening. Maybe you got some questions. No questions?
Thank you for the presentation.
Oh, thank you. Okay.